Welcome back. All right, so now we're going to graph y equals negative 2 sine 3x. Let's list our important features. First, the amplitude, if that wants to come up. There we go. Now, amplitude is always positive, and it's the coefficient in front of sine or cosine. So our amplitude is 2, but notice there's a negative in front. So our graph is reflected over the x-axis. Fix that. Whoops. What happened to the word X? Come on. Okay. All right, so now let's find the period. All right, so that's going to be 2 pi divided by b. B is the coefficient on x, so b is 3. So that's just going to be 2 pi thirds. And there are no phase or vertical shifts. All right, so now notice our table has changed. We have 4 columns. Woo, look at that. And that's because we have old x and old y. Our x is changed by the period change, and the y is changed by the amplitude, right? And the reflection. Right, both things are going to change the y values. We'll take care of them both at the same time. All right, so our old x values, of course, are 0, pi halves, pi, 3 pi halves, and 2 pi. You should have those memorized. The y values that go with those are the y values for sine. So sine starts at 0 and then goes to 1, 0, -1, and back to 0. Now let's change the period, change the x values because of the period change. And to find those values, we take the period and divide by 4. So that would be 2 pi thirds divided by 4, which is the same as 2 pi thirds times a fourth. Right? Dividing by 4 is the same as multiplying by a fourth. Right? So now that we could reduce that, right? We could cancel that 2 out. Divide those both by 2. And any day now, we have pi divided by 6. Right, so we're going to count by pi 6. So we're going to start at 0. And we're just going to count by pi 6. So 0 plus pi 6 is pi 6. Pi 6 plus pi 6 is 2 pi 6, which is pi thirds. 2 pi 6 plus pi 6 is 3 pi 6, which is pi halves. And 3 pi 6 plus pi 6 is 4 pi 6, which is 2 pi thirds. And notice that matches the length of the period, and it needs to, right? It's going to go through the important points, right? It's going to take one period. So our last value there should be the length of the period. And now let's transform the y values. We're just going to take those and multiply by 2 to take care of the amplitude change. But we're going to make it -2, right, because there's a reflection. So we just multiply our old y values by -2. And that gives us our new y values. Multiply 0 by anything, it's still 0. 1 times -2 is -2. 0 times -2 is still 0. -1 times -2 is 2. And 0 times -2 is 0. So our new points, I'll just put that here, points. The new points are our new x, which is due to the period change, and our new y, which is the amplitude change. Right, so we add the point 0, 0. That didn't change. So we got to start at the same point, and there's not going to be any change if you multiply 0 by something. Our next point is pi 6, negative 2. And then pi third 0. And then pi halves 2. And then 2 pi third 0. All right, so now let's label the graph. Let's see, we need to fit 2 pi thirds in there, so we could make that pi thirds. That makes this one 2 pi thirds, and that'll work out nicely because this would be pi 6, and this would be 3 pi 6, and 3 pi 6, right, because this pi 6, pi thirds is 2 pi 6. 3 pi 6 is the same as pi halves. That works out nicely with our graph. And then we have 1 and 2, and negative 1, negative 2. Now all we got to do is graph. So 0, 0, pi 6, negative 2, pi third 0, pi halves 2, 2 pi thirds 0. Right, there's our points. All right, so notice now our graph is going the other direction than what we're used to for sine because it's been reflected. There we go. All right. Still no change to domain. Negative infinity to infinity. The range now has changed because now we're oscillating between negative 2 and 2. Right? And another graph is done. You see how these aren't taking very long. Let's graph another one. And all of these are in your notes. And before we do that, though, let's just review. The x-coordinates of the 5 key points are as follows. So x1 is the value of x where the cycle begins, and that's always going to be 0, right? Because we're going to take care of any period changes before we take care of any phase shifts. And in this particular podcast, we won't see any phase shifts at all. So our starting value is 0. And then we just count by the period divided by 4. Right? That's all we have to do. That gives us our 5 values. And of course, the last value is going to be the same as the length of the period. All right, so let's graph. Now we have y equals negative 3 sine 2x. All right, we're going to graph one period. The amplitude is 3, and again we have a reflection, so we're going to reflect over the x-axis. The period, oops, missing a letter there. I have to say, it is chilly in this room. I'm trying to not chatter my teeth or have my hands shake of being cold. All right, so period, it'd be 2 pi divided by b, and our b value is 2. So that's just going to be 2 pi divided by 2, which is pi. And again, no phase or vertical shifts. All right, so we have our old x, which is the same values we've seen forever. All right, 0, pi halves, or it just feels like that, pi, 3 pi halves, and 2 pi. The old y that goes with those values is 0, 1, 0, negative 1, 0. Let's change the x values with the period. All right, so we start at 0. Oh, we didn't. Let's get our values. Well, we still start at 0, but we need to take the period, divide by 4, which gives us pi fourths. So we're going to count by fourths because we're going to be done at pi. All right, so 0 plus pi fourths is pi fourths. Pi fourths plus pi fourths is 2 pi fourths, which is pi halves. And then 2 pi fourths plus pi fourths is 3 pi fourths. Right? So we've got our x values. Now we just need the y values, and we'll get those by taking the old y values and multiplying by -3. So everything gets multiplied by -3. That gives us, oh, and this is amplitude. And of course, we have a reflection as well. Yep. And so 0 times -3 is 0. 1 times -3 is -3. 0 times -3 is 0. 1 times -3, excuse me, -1 times -3 is +3. And 0 times -3 is 0. That makes the points that we're going to graph. New x, new y, 0, 0, pi fourths, -3, pi half 0, 3 pi fourths, 3, and pi 0. All right, so let's have our graph go up by fourths. That would make things nice and easy for us. All right, so this would be pi fourths. This would be pi halves. This would be 3 pi fourths. And one period is done at pi. And it'd be nice if our graph had more vertical lines on it, because we need 1, we need 2, and I guess I'm extending this graph so that I can have 3. And I need to do the same thing in the other direction. -1, -2, and oh, things are getting a little close here, -3. All right, so now let's just graph our points. 0, 0, any day now. Pi fourths, right in the middle of our x, -3. Pi half 0. 3 pi fourths, 3, way up here. And then pi 0. So you can see our graph has been horizontally compressed. Now things only take pi to finish up a cycle. And this graph is vertically stretched because we have an amplitude change, and reflected. There we go. So there's one period of our graph. And the domain, of course, all real numbers. Range, now we're oscillating between -3 and 3. And we're done with another graph. Aren't too many of these left. Let's graph this one. So we have y equals -3. That's another -3. Y equals -3. And of course, my graph only goes up to 2 here. Y equals -3 cosine pi x. And I'm going to graph 1 period. All right. So amplitude. I must have just really wanted to graph a lot of reflections. Amplitude is 3, right? It's the absolute value of the coefficient in front of cosine. We are also reflected over the x-axis. Got a new period here, because b is not 1. B is pi. Right, so period is going to be 2 pi divided by pi. Well, that's just going to be 2. Right, so now we're counting by 2. And let's fill in our table. We have our old x, which is 0 pi halves, pi, 3 pi halves, and 2 pi. We have the old y that goes with it, and that's 0, 1, 0, -1, 0. Let's change the x values by changing the period. Come on. There we go. E looks funny. That looks a little bit better. All right, so take the period, divide by 4, and that gives you what to count up by. So 2 divided, whoops, no pi's. First time we haven't had one with a pi in it. Right, so instead of a number like, so if there was a pi in there, it'd be like multiplying by 3.14, right? Well, now it's just 2. So the period, we take 2 divided by 4, that gives us 1/2. Right? So we're going to count by a half. We start at 0, right? And 0 plus 1/2 is a half. 1/2 plus 1/2 is 2 halves, which equals 1. 2 halves plus a half is, oops, no pi. I don't know. I just feel like I need to make a pi, I guess. Even though I know that it's going to be 3 halves. 3 halves plus a half is 4 halves, which is 2, and that matches the period. So that's our new x values. We need the new y values, and we'll get that from the amplitude / reflection. All right, and we're just going to multiply everything by -3. Well, not everything, just the y values. We're going to multiply the y values, all 5 of them, by -3. Pretty easy multiplication here. That's going to give us 0, -3, 0, 3, 0. Notice I'm going pretty fast here. That's because I think you guys can handle that. You know what 0 times 3 is. So our new points are, right, so it's our new x and our new y. Just waiting for a new y to come up. What happened to new y? How about now? I'm afraid to pick up the other pen. Come on. Y. Ah, finally. Oh my gosh. I was going to die of boredom there. 0, 0. Come on. 1/2 -3. Oops. Yeah. What happened to that 3? 1/2 -3. There we go. And then 1, 1, 0. Got to make sure we use the right columns. You can always circle your columns, by the way, too, so you choose the right values. 3/2, 3. And 2, 0. All right, so there are our points. Let's label the graph. All right, so we should count by a half. Right, so this would be a half. That would be a half. That would be 1. This would be, that 1/2 looks a little funny. I think my line and my 1 became 1. 1/2. 3 halves and 2, right? Our graph ends at 2. And I'm going to have to try to stretch this -1, -2, -3, 1, 2, and way up here will be 3. There, we can be creative. All right, let's just graph our points, and this graph is done. So we have 0, 0, 1/2, -3 down here, like on my chart. 1, 0, 3 halves, 3 way up here, and 2, 0, and there we go. Let's graph. Right, so again, graph is reflected. It is vertically stretched. What about horizontal? Well, 2 is certainly smaller than 2 pi, so it has been horizontally compressed. The domain never changes. Should never miss that question. And we are now oscillating between -3 and 3. And this graph is done. Let's graph another. We're going to graph until we see a screen that says phase shift, and that's going to tell me to stop. Yay, it's not a 3. It'll fit on my graph. Y equals 2 cosine pi halves x. Amplitude is 2. Period. We're going to take 2 pi, divide by b. B is the coefficient on x, so that is pi halves. All right, so that's going to give us 2 pi divided by pi halves, which is the same as 2 pi times, so if dividing by pi halves is the same as multiplying by 2 over pi, right? Dividing by a fraction is the same as multiplying by the reciprocal. The pi's are going to cancel, so no pi's again. This time our period is 4, right? So the period is 4, right? And we need to find where our new x values are going to be. So we take the period and divide by 4, and well, this is just going to be any easier because that's just going to be 1. Right? And then again, no phase or vertical shifts. Just as a reminder. All right, so we have old x, which is, of course, 0, pi halves, pi, 3 pi halves, and 2 pi. We have the old y's that go with those because we're going to get new x's from the period, new y's from the amplitude change. So new old y's are 0, 1, 0, negative 1, 0. All right, let's change the x values with the period change. We simply start at 0 and count by the period divided by 4, which in this case is 1. So it can't get any easier. 1, 2, 3, 4, like you're in first grade, right? You count by 1. And then we have the amplitude change, and that will give us our new x and our new y. So take your amplitude and multiply those old y values by your amplitude. Right, so all those 5 numbers get multiplied by 2. And when we multiply by 2, we get 0, 2, 0, negative 2, 0. Right, couldn't be any easier. Right, and so let's write down our new points, and then we'll label our graph, and we'll graph, and this one will be done. That looks better. All right, so points. I like to write them down so I don't grab the wrong values and then I have to erase my graph because my graph looks all wonky. 0, 0, 1, 2, 2, 0, 3, negative 2, and 4, 0. All right, just looks like regular points, doesn't it? And our graph should go up by 1. That will allow it to fit in nicely, and these will go up by 1 as well. By the way, on the graph where they didn't fit, I could have gone up by something else, but I didn't think that going by a half really made for a great graph. So I just stretched it out a little bit. But now I don't have to worry. That fits perfectly. So we have 0, 0. Uh-oh. Uh-oh. Guess what I just put in there? Oh, Ms. Majagna. I guess I got too used to graphing sign. We just need to fix the y values. All the other values are good. Because guess what I put in there? That's what happens when you go too fast. So I have to look way up to see my equation. We are graphing cosine, not sine. Old y values for cosine. Cosine starts at its max. 1, 0, negative 1, 0, 1. Hopefully you would have realized after we were done and we looked at the graph, hey, that's not a graph of cosine at all. Unless I didn't look at the equation when we finished either. All right, so let's just fix that. All right, so there's no our old x and our new x, those were fine, right? Where we had a problem was with our y values because I accidentally wrote down the points for sine, not cosine. Now all is good. You're probably thinking, what is Miss Machadna doing? She's writing down the wrong values. Now let's multiply by the amplitude. So all of these get multiplied by 2, and that will give us our real values. I'm glad I looked up to see that I was graphing cosine, not sine. Equals 2. That happens sometimes. Equals 0. So just make sure you remember who you're graphing. Equals 0. Equals 2. Now we have the points. That goes with cosine. And so we have 0, 2. We start at the max. 1, 0. 2, negative 2. 3, 0. And 4, 2. And remember, it's okay to make a mistake. We all make mistakes. You just, when you realize it, you fix it. All right, 0, 2. Starting here, not down at 0, 0. 1, 1, 0. 2, negative, or excuse me, 2, negative 2. Oh, and speaking of that, why are there no negatives over here? All right, is it going to come on? Did it not notice that there we go. And then 3, 0, and 4, 2. And now that looks like a graph of cosine that has been, this case we have been horizontally stretched, right, because 4 is larger than 2 pi. No, we haven't. We've been 4 is smaller than 2 pi. Never mind. We have been horizontally compressed. 4 is definitely smaller than 2 pi because, well, that's a great. 2 times 3 would give us 6. So 2 times pi is greater than 6, and certainly 6 is greater than 4. So we've been horizontally compressed, vertically stretched, and that's a horizontally compressed, vertically stretched graph of cosine, and that one is done. And now let's graph the next one, if there is one. Let's find out. Oh, domain and range. The domain, negative infinity to infinity. The range, we are now oscillating between negative 2 and 2. And come on. There we go. Anybody else? Is that the last one? Let's find out. It is the last one. Thanks for watching. Bye for now.